So the exercise we did on Octave basically let us take different f values and add them together. These were the 4 f values that we looked at. So now let's look at how we can start adding some of these together. Here was my f1, another f2, f3, f4. I've just showed them on top of each other. If we start adding them, what happens? Well, then basically what we have to come up with is an equation like this, which basically says that f target here is a summation that goes from 1 to n, where n is how many of them we want to add, the amplitude, and again the same function we looked at. So now let's actually start adding them one by one. If I just add the first two, f1 and f2, this is the signal profile I get. If I add 3, and again here I'm keeping the amplitude constant between 0 and 1, I would basically start seeing this pattern. f4, this pattern. You saw that in the exercise we just did. What happens if I now start going for a lot more? So if n goes from not just 4, so initially we basically looked at n was equal to 4, but we really want to go a lot more, right? So what happens if I now go for n is equal to 10? N is equal to 50. Now you would actually kind of see that in some instances, this signal and this signal are approximately similar. They have a peak at 1, 2, 3, 4, 0, but it's kind of flat between. Of course, it still has a lot of signal here, but overall, it's actually trying to mimic the signal. So in the limit, if n was a much, much larger number, you would actually see this to be true, that this would actually become a signal that repeats and has the same characteristics as that. That's what we want to learn about how to do. So in essence, by just taking sines and cosines, and by mixing them up together correctly, we can actually recreate a signal that we're interested in. And again, in this case, I showed a very simple signal, but we want to be able to do this for more complicated ones too. But more importantly, it gives us another way of looking at a signal.